Hello student, today we are going to study the selection sort algorithm. Selection sort algorithm is one of the easiest approach of sorting. It is inspired from the way in which we sort the things out in day-to-day life. It is an in-place sorting algorithm because it uses no auxiliary data structures. The in-place sorting techniques are the technique which stores the data inside the CPU, and they do not use any auxiliary source. There are some external. These are called the internal. These are called in-place sorting. There are certain external sorting algorithm which uses some auxiliary data to store and sort their data. So this is an in-place sorting technique. The selection sort algorithm techniques find the small first of all find out the smallest element in the list, and then it switch that element with the first element. Then it find out the second smallest element, and then it swap with the second element in the unordered list. Similarly, it it run for the n number of elements, and finally we get the sorted array. For example, in the list, there, suppose there is a list that is the 6, 2, 11, 7 and 5. Here the we first find out which one is the smallest among all these. Simply, I am not discussing about this step, I am just discussing right now about the simple logic behind the selection sort algorithm. And in this technique, first we shall find out that the 2 is the smallest, in this list 2 is the smallest element integer. So we shall switch the its smallest integer with element at the position number 1. So 2 and 6 will switch their position. After that, we shall find out the second smallest element, that is 5. Now the 5 is the smallest element, and it will be switched with the second element in the list. As 6 at the second position after first switching, so 6 and 5 will switch their places. Likewise, we go through the array and we shall get the final sorted list. The selection sort algorithm has following pseudocode. The first code is for I equals to 0 and I less than n minus 1, I plus plus. In a loop is started. In this loop, we start with the first element and run for the n minus 1th element. Here we do not, as when we are left with the single element, then that element is already the largest one and we need not to sort this. So we run the for loop for the condition from I is equal to 0 to n minus 1 I plus plus up to n minus 1 only. After that, we shall start indexing we shall start a variable index, and that index will start from the very left side of the array, and for that we shall perform the second loop and travel through the array, in which for I is equal to 1 from the element on the we shall travel to the element on the right hand side till the end of the array. Okay, then the second loop for j equals to I plus 1 means from the place where we started, we shall move toward the right side. And after that, we shall check out the condition, is there any element for which aj is less than a index. Means if there is any element which is smaller than the element at which index was pointing. Index was the element which we assumed as to be smallest, but if we find out some element which is smaller than the indexed element, then in that condition we shift our index to the j points. Suppose at position number j we have found as an element smaller than the indexed element, then we shift the index to the j, and after that we temp is equals to ai, and we shift the previous element which was at the first position into the temp, and a index and the index and the previous element at the position of ai. In ai is the position where we have the ai. Now at index we have already placed the smaller element, and we shall place that element at that position AI. In this way, we are we are well familiar with these three steps. Simply, we can say that if we have to start with the left hand side, if we get if we got any element which is smaller than this element, we we shift our index pointer to that position and switch that position element with the position number I element. Here I is the variable to traverse the array. I will start from the 0th position to the right hand side of the array. The index is the variable to store the index of minimum element. As I've told you, index is the variable which marks the smallest element in the array. And j is equals to variable to traverse the unsorted subarray. And j is the variable in which we travel to the right hand side to find out that is there any element smaller than the index element. And temp is equals to the temporary variable used for swapping. Temp is just a temporary variable used for swapping. We are well aware with the swapping. So what we did in this coding, we traversed the route. We started from I is equal to 0 and travel to the nth minus 1th element. We mark the first element as we assume that the first element is the smallest element, and marked it with indexed. And we after that we move towards the right hand side, and if we got any element which is smaller than the indexed element, then we switch those two elements. So this is the simple logic of selection sort algorithm. Now the execution of the selection sort algorithm. The suppose we have elements 6, 2, 11, 7 and 5. These are the 5 elements in the array that we have to sort using the selection sort. So for that, as I have told you in the sorting technique, we shall start a for loop and start the for loop. Suppose we assume that the 6 is the smallest element and mark the index to the 6. Index marks the minimum number, and we mark the index to the 6. And after that we follow the second loop, in which we find out is there any element on the right hand side in the array till the end of the array which is smaller than our index element or 6. Then we find out that 2 is the smallest, so we find the minimum element and swap it with the first element. We find out that the 2 is the element which is smaller than 6, so we switch these two elements. After switching, the array looks like this: the 2, 6, 11, 7 and 5. So here the element has switched their position, and we start finding the minimum element, and now the index value will shift to the position number 2. Here we start finding the minimum element, and on moving towards the right hand side, that there is an element 5 which is smaller than 6. So what we do, we shift the pointer to the right. We switch the position of 5 and 6 with each other, and after this switching, we move for I equal to 3. We mark the index at 11, and we find out that is there an element which is smaller than 11. Then in that situation, we find out the smaller number, smallest number in the right traversal. So there are two. Look here. Here there are two elements, 7 and 6. Both are smaller than 11. But in this step, we find out first we shall shift the index to the 7th position. Then we shall keep on moving towards the right hand side and find out that this index has moved towards to the 6th position. Because the index can move to this position number 5th, we switch these two numbers. After this switching, the array look like that: 2, 5, 6, 7, 11. Here now the index is at I is equals to 3. So I equal to 3, the element is 7, and on its side there is no element which is smaller than 7. So we end up we exit out of this for loop, and the final array is a sorted one. So finally, at the end, when I equals to 4, then we finish the the for loop, and the final sorted array look like this. So once again, by stepwise, we have started from the I equals to 0. Array is index 0, 1, 2, 3, 4. Then the index shifted to the position number 1, then index shifted to position number 2, after that index I equal to 3, and finally at I equal to 4, it the loop finished. So with each loop cycle, the minimum element is unsorted, subarray is selected. In this way, we can say is that in each um, loop, we find out the minimum element, and then the minimum element is switched with the position of the index to at the starting. It is then placed to the correct location in the sorted subarray list until A array is completely sorted. The time complexity of the selection sort algorithm consists of two nested loops. Owing to the two nested loops, it has the O(n) square complexity, because first loop run for the 0 to n minus 1th element, and second run for the also for the n minus 1 element. So n minus 1 into n minus 1 is its order of n square all. So its complexity is O(n) square. So the selection sort shows the consistent time complexity of n square in best case, average case, and worst case. It's not like the insertion sort, which in best case shows the complexity of n, which we have already studied, and but it's shows a uniform behavior and same complexity in best case, average case, and worst case. The selection sort is an in-place algorithm. It performs all the computation in the original array, and no other array is used. Hence, the space complexity works out to be O(1). Since it is an in-place sorting algorithm, so it's just require O(1) space complexity. Selection sort is not very efficient algorithm when data sets are large. This is indicated by the average and worst case complexity. The selection sort uses minimum number of swap operations, O(n), among all the sorting algorithms. So in this way, the selection sort algorithm, I just give you a brief overview of all this. It's very easy algorithm. It shows a consistent behavior and time complexity of O(n) square. This is the very simple in the way that first we find out in each iteration we find out the minimum smallest number, and then we switch that element with the uh, position where index was placed at the starting in that iteration. So in this technique is there are two for loops, and it's very simple, and it shows consistent behavior. Like like in this first loop, first index was at 6 position number, and in second loop index was at position number 2, at third index number 3, at 4 index number 4, index number 5, and in each iteration we found the minimum number in the list, and finding the minimum number of the list, we switch that number with that index. For example, in first iteration, we switch the smallest number with index number 1. In second iteration, we switch the next smallest number with position number 2. In third iteration, we switch the third smallest number with position number 3. And we place the fourth smallest number at position number 4. And in fifth and last loop, we place the fifth smallest number at the end position. In this way, the array get sorted. So that's all about this selection sort.